What is ETL? Extract, transform, load. Basically, every traditional ETL tool operate on the basis of first extracting the data from heterogeneous sources, like various sources, and then by transforming the data in middle tier engine. Basically, it is a proprietary middle tier ETL engine that is basically used as a staging area, and finally it loads the transformed data into the target warehouse server. Sometimes the target server can be an integration server, or in a big data terminology technology, like it can be a Hadoop cluster as well. If you notice in the diagram, basically the data transformation step is dedicatedly performed by the proprietary ETL engine, on a dedicated server. So the ETL engine performs data transformations. Sometimes it also performs some data quality checks on the proprietary engine, but these operations are always on row by row basis. So because of the row by row operations, it leads to a bottleneck in the overall integration process, and leads to performance issues. In addition to that, the data must be moved over the network twice. If you look at the diagram, basically the data is moving the network twice, once between the sources and the middle tier ETL server, and again from the ETL server to the target warehouse server or Hadoop clusters. So the data is moved over the network twice, once between the sources and the ETL server, and again between the ETL server and the target warehouse server, sometimes in a Hadoop cluster. Moreover, if we want to ensure referential integrity in the integration process, basically it compare the data in the staging area against the values from the target data warehouse. In order to do that, the reference data must be downloaded from the target server to the middle tier engine, and it leads to additional network traffic and additional download time, and finally it leads to the additional performance issues. Because of all the issues raised by ETL architectures, basically we go for ELT architecture. Basically this new approach changes where and how the data transformation takes place, and also it leverages existing developer skills, RDBMS and big data engines, and server hardware to the greatest extent possible. So the developer has a full flexibility on what he is developing, and he uses the hardware and software to the greatest extent possible. So it changes the order of execution steps. Basically it extracts the data from source tables first, then loads the data into the destination server, that is the target warehouse server or Hadoop cluster, and then finally transform the data on the target server by using target or DBMS native SQL operators. Because of this approach, it increases the performance because it uses the hardware and software to the greatest extent possible, and it always generates native SQL operators which is written for the target hardware and executed in the target hardware. The important note here is Oracle Data Integrator 12c supports both ETL and ELT style data integrations. Basically you can implement ETL mappings as well as ELT mappings, which we are going to see in the coming sessions.